Hello, everyone. I'm here with an optimization question that a few people have asked about, so I wanted to go over at least how to get this one set up. Okay, so I want to draw a picture here. So the graph of square root looks something akin to that. I've got my point here, 4, 0. And then I have some point on this graph, let's call it x, y. And the thing that this asks me to do is to minimize this distance. So I'm going to call that d. And so the thing to optimize here is d. And we'll figure out what that is in a second. And then my constraint is that y is the square root of x. Okay. And I think I did an example like this in the class at some point, but it's going to be a lot nicer for us if we rewrite this constraint as x equals y squared, because I would rather not do anything involving square roots where I can at all avoid it. Okay, speaking of square roots, what is this distance? Well, I have to note this is a right triangle here. And so this side, it is 4 minus x. And this side is y. So my distance formula here is the square root of 4 minus x squared plus y squared. Okay, now I can substitute my equation here into this. So that's going to tell me that the thing I'm minimizing here is the square root of 4 minus x squared plus, and y squared is just x, so just plus x. Okay, I'm going to multiply this out. So this is the square root of 16 minus 8x plus x squared plus x, which is the square root of 16 minus 7x plus x squared. Okay, so that is my distance of this line in terms of where I put this point x, y. Now that I've written this in terms of one variable, I can now take the derivative. So I'll get that d prime is 1 over twice the square root of 16 minus 7x plus x squared. But then by the chain rule, I have to multiply by the derivative of the inside piece. So that's going to end up being minus 7 plus 2x. It's going to live up there in the numerator. And now I'm almost done with this question, because now I can say, okay, where is this derivative 0, which is going to happen where the numerator is 0. The denominator doesn't have any role at all. So I'll get minus 7 plus 2x equals 0, so 2x equals 7. So x equals 3 over, or sorry, x equals 7 halves, which is 3.5. So it's like a little bit over to the left of this point 4, 0 is where our answer ends up being. And so then we also want the y coordinate, but remember, the x coordinate is the y coordinate squared. So the y coordinate is the square root of the x coordinate, so y here is the square root of 7 halves. Okay, and so that will work out to be our optimum. Again, if you want, you can check sort of what are the endpoints, and you should check at least this endpoint on the left. At this endpoint on the left, x is 0 and y is 0, but that's visibly a distance of 4, and 4 is greater than this square root of 7 halves, so that's worse. Whereas there isn't really an endpoint over here if I just sort of follow this curve and go woo out here. then I'm going to end up way further away from this point than that point. So this has to be the actual minimum that I'm looking for. Okay, that's it for problem 10. Until next time, be well.